Good morning to all. We are going to see the subject control systems. The topic what we are going to see now is time domain specifications from Unit 2 Time Response Analysis. This is Divya, working as Assistant Professor in the Department of ECE, R.M.K. College of Engineering and Technology. Let's get into the topic now. Time domain specifications. These are the parameters that we are going to use to analyze the system when in time domain. The transient response characteristics to a unit step input is specified in terms of time domain specifications as delay time, rise time, peak time, maximum peak overshoot, and settling time. These are the 5 parameters or specifications that we use to analyze our system when the input is unit step. This is the response of a system to unit step input. Here you can see here delay time, rise time, peak time, settling time, and here you can see peak overshoot. This is the amplitude parameter and these are the time parameters. Delay time, as we can see here, it is the time taken to reach 50% of the final value. Rise time you can see 100%, and peak time you can see the peak value, time taken to reach the peak value of the output. And settling time you can see, we can say like the system output has to settle within predetermined value. So this is the range of the determined value. Your output has to settle within this value. Time required for that is called as settling time. Now we'll see the definitions of them one by one. Delay time, symbol for that is TD. It is the time required for the response to reach 50% of the final value for the very first time. Rise time, symbol is TR. It is the time required for the system to rise from 0% to 100% of the final value for the very first time. And this value differs when the system type differs. The system is underdamped system. The percentage is from 0 to 100%. The system is overdamped system. The percentage is 10% to 90%. System is critically damped system means the percentage rise from 5% to 95% is considered as rise time. Third one is peak time, symbol for that is T suffix P. It is the time required for the response to reach the peak value for the very first. Maximum overshoot or peak overshoot, symbol is MP. It is the ratio of peak value to the final value where the peak value is measured from the final value. And final value symbol is C of infinity, and the peak value or maximum value occurs at time t equal to Tp, that is peak time. So the value is C of Tp. The formula for peak overshoot is C of Tp minus C of infinity by C of infinity. Fifth parameter is settling time, T suffix S. It is the time required for the response to reach and stay within the specified tolerance band. In general, the tolerance band what we use is 2% or 5%. This is the two values that we use in general. And the formulas for all the 5 parameters: delay time 1 plus 0.7 zeta by omega n, rise time pi minus theta by omega d, peak time pi by omega d, peak overshoot or maximum overshoot e power minus zeta phi by root of 1 minus zeta square. If it is percentage overshoot, that value has to be multiplied by 100. Settling time, we have 2 different formulas as we have 2 tolerance values, 2% and 5%. So the formula is 4t and 3t, where t is equal to 1 by zeta into omega n. Now we'll see the parameters zeta, omega n, omega d, theta. We have different values incorporated in these formulas. Let us see them. 1. Zeta is damping ratio. Omega n is undamped natural frequency of oscillation represented by radians per second. Omega d is damped frequency of oscillation, unit is radians per second. And the damping ratio definition is it is a ratio of actual damping to critical damping. Depends upon the value of zeta, your system can be classified into undamped system when the zeta value is equal to 0. If the value of zeta lies between 0 and 1, then the system can be called as underdamped system. If zeta value is equal to 1, the system can be called as critically damped system. and when it is more than 1 we call it as overdamped system. These are the 4 categories of your system based upon the value of zeta. Now we can see here, a critically damped system has reached the final value. Underdamped system is a process of oscillation, and overdamped system damps very quickly. We have another notation, omega d, damped frequency of oscillation. We have a separate formula for that too. Omega d is equal to omega n into root of 1 minus zeta square, and theta is a formula. We have a formula for the value called theta incorporated in that our time domain specification. Theta is equal to tan inverse of root of 1 minus zeta square by zeta. While you are solving your problems, while using calculator to find the value of theta, your calc should be in radians mode only, as theta is in radians. And general second order system transfer function, that is CFS by RFS, that we require for all solving problems in the unit 2, it is omega n square by s square plus 2 zeta omega n into s plus omega n square. From this only we will be getting our final notations, omega n and zeta value, that we will be using in all the formulas of time domain specifications. Thank you. We'll meet again in the next video.